Hello everyone. In this week, we will work on the frames. So the objectives of this lab is to understand the different frame types, such as word frame, also called base frame, reference frame, also called user frame, and tool frame. So for this lab, we will focus on the tool frame and the reference frame. So first, let's look at the reference frame. A reference frame defines the position of an object with respect to a robot in terms of position and orientation. So a reference frame, you can save a lot of time on programming if you move the objects to different location. So under this situation, you just need to reteach the reference frame. Your program will stay with new reference frame. So let's look at the reference frame first. So let's have the robot. We can open the Panic robot in this way. Okay, this one. And we add a tool. We use a pencil, okay, small pencil. And we need to adjust the TCP. Double click here. Adjust. Okay. Use the right button on your mouse to rotate the robot. Okay, so we need to get more. Okay, now it looks good. So we need to add another workstation. Open the welding table. Okay, this one. So for now we have the tool is the pencil, and we have the working station. It's a welding table, and we have the flange is here. Let me zoom out. Okay, here is the base or base frame. Okay, also called the word frame for Fanuc robot. If we don't assign the reference frame or the positional that will respect to here base frame. Okay, and here is a tool frame. The tip of the pencil will be the origin of the tool frame. Okay, and here is the flange is used, or faceplate is used to install different tools for the welding, machining, or a gripper for pick up and place. So now we have our basic tools and frames, and we just to create a few targets. So I will draw the robot to the in the direction. Press Alt key and move in Y direction. Okay. So I am going down a little bit. Okay. To avoid the singularity problem, so I adjusted the robot here. And let it be x positive. Okay, here is the first target I will want to create. So you can just press this button at the target, or yes, you can just add a target here like this. And if you want to jump to the other place, you can have another two targets. We suppose you can jog the robot like this. Okay, press Alt key. Okay, because target 1 and 2, 3 is the same position. So we need to reteach. So we can right click this one and teach current position as the position for the target 2. Or you can just jog the robot to the position and then add a target. And we need to have another target. Okay, this is for target 3. Reteach that. Sorry. One, two, three. Oh no. Teach current position as the target 3. Okay, let's check that. Okay, so we have the 3 position, and we want to create a program to trace the path V victory. Okay, V for victory. So we have the program, and start from target 1. So we choose the target 1 and have the linear motion type. Okay, and then move to the target 2 and the target 3. So let's check the program. Okay, so we have the V for victory, and you can see from the program we have the reference frame. It's the base frame for the Fanical robot because we didn't have set up or define other reference frame. And we also have the tool frame. This is tool frame. It's a pencil, the tip of the pencil for the origin. So basically, these two frames, reference frame and tool frame, will define the position date for the target or object. Okay, let's look at the position date. Double click the robot on the station tree. You can find the robot name, okay, and you can find the tool frame with respect to the robot flange. Robot flange is here. Okay, this is the flange. We also call it the faceplate. It's used to install different tools, okay, like welding gun or the gripper or the pencil. And here is the position date with respect to the robot flange. And the second line is reference frame with respect to the robot base, because we use the base frame as the reference frame. So this data will be 0. Okay. And here is the tool frame with respect to the reference frame. Tool frame with the reference to the base frame. Okay. So we have this kind of the position date. So next we will define two reference frames. So I'm going to add a reference frame by press this button on the toolbar. Okay, double click this frame 2. You can find the position data for frame 2. This reference frame with respect to the base frame. Okay, and the position data is 0 in X and 1000 in Y. So we change this one and negative to 50. And you can see now reference frame is moved to the left of the robot. Okay, now reference frame is here, okay. And for the target 1 and to target 3, you can right click the options. You can find the positional data for the target 1. Now the target 1 is with respect to the base frame here. Okay, this shows base frame. This is the base frame. So if we drag the target to frame 2, okay, like this, and we choose this target with the frame 2 with the reference frame 2, you can see what happened. Target 1, okay, because I didn't write down the numbers. Okay, did you see the changes of the target? Okay. Okay, let's check the position data for the current target 1 is 256 and 304 and negative 323. So this is the position data with the reference to with respect to the robot base. So we have the reference frame here. So I drag the target 1 with respect to the frame 2. You can see the positional data didn't change, but the target is run to here. So now with the same positional data with respect to the frame 2, so the target will be moved to the other place. Okay, we can also do in this way. Before to do that, I move that back to the base frame. So we can right click each target and change support to use frame 2 as the reference frame. Okay. So what happens if you run this program? Let's check that. You can see robot move to here to write the letter V. So it's not the previous position because we set this reference frame, the base frame as a reference frame. So if we check to change the reference frame as frame 2, see what happened. Okay. So we have the problem singularity. Okay, so probably will not run. Let's try change to the join movement. It's better. Okay. See, they will move back, have the previous position. So this is how to use the reference frame. And the important thing is that we can have more than one reference frame, but only one can be activated. For this case, now the reference frame 2 is activated. Okay, so we have the some mark here, which means reference to frame 2 is activated. So sometimes we can have the activate the reference frame, base frame. Now this one is activated. So when you create a program, only one reference frame can be activated because you cannot donate the TCP reference with respect to the two reference frames. Okay, and for the real robot, we need to learn how to teach the reference frame. For the Fennec robot, it's also called the user frame because a reference frame is defined by the user or programmer or operator, depend on the needs of the different objects or different shapes of the objects. So when we need to define the reference frame, because for this reference frame, I just have a very simple example. I have the negative 250 in y direction. Actually, in a real situation, we have different shapes for the parts we needed to define to teach the robot. So how to do that? We have the defined reference frame here. Okay, and basically we have 5 methods to define the reference frame or teach the reference frame. 3 point in y plus or origin, and 6 points or turntable, one axis, one x, and 2 axes. So we will have OpenLab to let you know how to teach the user frame or reference frame. Okay, and here I have the lab instruction for you to learn how to teach or calibrate reference frame on the RobotDK. So you can check by yourself. When we work on the robot programming, we just use base frame because this is a very difficult to understand or use that in the simulation. If you have a few reference frame, your program probably will have a lot of errors. Okay, because you sometimes we don't really understand the positional data for the TCP, and when we have the another reference frame, you don't know robot where to move. Okay, this is very dangerous. So for the rest of labs, we will use only the base frame and the reference frame. Another things I want to show you about is the use offset for the programs. So I put it back to the base frame, and I delete this frame. Okay, and we copy these programs by press the shift key together, choose all of them, and then release that and paste here. So I have too much the programs. I don't know why. Delete that, and we can see we have the same movement with the program 1 and the program 2. So I just okay. So we can have the same motion for the program 1 and the program 2. Now we choose these 3 movements and right click, offset the targets. You can see here we have the numbers. So we change to 0. For this one, we use in x direction, we use -100. And for 500, okay, let's try what happened. You can see the all targets move here. Let me check this if this program can run or not. So we have movements. So based on this information, we can change the motion type to join move by right click each motion instruction and double check again. So we can use this offset to have the same program to move that. I don't suggest you guys to use this function because they will have uncontrolled movement for the robot. For the real robot, you will out of control the robot. Probably you will have the accident for the robot. Okay. Okay, another frame we needed to take a look at is tool frame. Tool frame is used to describe the orientation and the location of the physical tool on the robot. So you need to remember, by default, the tool frame have the origin at the center of the tool. So for the pencil, the origin of this tool frame will be the tip of the pencil. And for the welding gun, it's the same thing. The tip will be the origin of the tool frame. So we can have the same procedure to calibrate or define the tool frame by press the utility and find this button. And you can select the methods to define or calibrate the tool frame. So for this video, I will not show any more about the tool frame and the reference frame. So if you are interested in the frames, we will have open lab to teach you how to teach the robot the user frame and tool frame. Okay, so that's all for this video. Thank you.